So we'll pick up here where we left off in our last discussion of the p-value of 0.921 for our chi-square test. But before we do that, let's put our discussion in context. We'll be looking at equivalent proportions and tests for equivalent proportions, the second part of our talk in week 4. We're talking about how exploring data can help us to find opportunities to further define our data, to create new categories to help us understand it so that we can more effectively analyze it. And in this segment, we're talking about differences in proportions when we have categories that are comparing two categories with two other categories. And we started by talking about that analysis in large groups using the chi-square test. And the chi-square test assumes that you have large groups, or that each square in your 2x2 table has at least 5 observations in it. But if we flip back to our SPSS output, let's see if that assumption held true. So here we see, when we're comparing the contiguous versus the outlying United States, that the outlying United States had only 3 observations for facilities that gave discharge instructions less than 25%, or less than the 25th percentile, and only 4 facilities that gave discharge instructions greater than or equal to the 75th percentile, which was 100% of the time. So you can see here these very small numbers violate the assumption of the chi-square test. And hence in your output you get this footnote A, that more than 20% of the cells have fewer than 5 observations. So we can see that ourselves, and SPSS has clued us into that fact so we can interpret this p-value with caution. But although the p-value has to be interpreted with caution in this particular example, I still want to do the work to interpret it before we talk about what else we can do about these small cell sizes. Just to remind us, the null hypothesis of the chi-square test practically says that the outcome is independent of the predictor variable. So we're looking at 2 different variables that have 2 different levels of observation. And essentially, the chi-square test is testing if there is a relationship between them. And the null hypothesis is that there is no relationship between them. So let's see how this null hypothesis relates back to our SPSS output. So the null hypothesis is there's no relationship, but this p-value of 0.921 is much, much, much higher than the standard threshold of 0.05. So with that in mind, take a second to look at the null hypothesis in this p-value and decide if you are going to reject the null hypothesis or fail to reject it. So of course, with this extremely high p-value and our null hypothesis, again, of the chi-square test, that the variables are independent, that there is no relationship, with a high p-value, we would reject the null hypothesis that there is no relationship. So practically, it suggests that there is a very strong relationship between whether or not a facility is inside the contiguous United States or not, and whether or not they give discharge instructions greater than 75th percentile or less than 25th percentile. But we know that even though that's how we would interpret the p-value, that we cannot use the chi-square test in this situation. So I want you to know how to interpret it, as it may be relevant for variables in your particular question. But now let's turn our attention to how we could handle a situation like this where we have so few observations. Well, fortunately, there's a statistical test for this. When we have very small numbers in our cells, or small groups, we can use the Fisher's exact test. It's also called Fisher's exact test of independence. Again, testing if there is independence of the predictor and the outcome, or if they are related to each other. The null hypothesis of the Fisher's exact test is just like the chi-square test, that the rows and the column variables are independent of each other, or that there's no relationship between the two. So let's run the Fisher's exact test on these data and see what we find. So back in SPSS, we'll go to our favorite tab, the Analyze tab, and we're going to select Descriptive Statistics this time and go to Crosstab. Now, I already have populated it with the discharge instruction dichotomous variable based on our percentiles, and then whether or not the facility is in the contiguous or the outlying United States. Now let's select statistics and run the chi-square test. Now this time, when we selected the chi-square test, it gave us a lot of other statistical tests as well. So even though we selected chi-square under the cross tab, our output is giving us more than we told it to. And this is by default. It gives you these outputs. You see here the Pearson chi-square test of independence is the exact same value that we obtained when we ran it using the other command of 0.921. But we already know that with these very few small counts of 3 and 4, the chi-square test is very unlikely to be reliable. So that's why we're running the Fisher's exact test of independence. And here, we're looking at the two-sided exact significance level. So this is the p-value of 1.0. So take a moment and interpret this p-value in light of the null hypothesis. What does it practically mean? So the Fisher's exact test null hypothesis practically is that the outcome is independent of the predictor, or being in the contiguous United States versus the outlying United States is independent of the proportion of patients that are receiving discharge instructions at the 25th percentile and below, or the 75th percentile and above. Now with that null hypothesis and a p-value of 1.00, what should we do with that null hypothesis? We should certainly reject the null hypothesis. So we would conclude that there is a relationship between outlying contiguous United States and proportion of patients receiving discharge instructions at the 25th percentile and below, and the 75th percentile and above. So we see that there's a relationship between those two variables. The Fisher's exact test and the chi-square can't tell us how strong or how powerful that relationship is. You can just suggest that a relationship does in fact exist. And then we can use that finding to further support other analyses or other statistical modeling. So with the Fisher's exact test, of course, every statistical test has assumptions. Here, group size is not important as it is in the chi-square test of independence. Here you can use the Fisher's exact test for groups that are have cell counts less than 5. It works very well when you have greater than 5 cell counts, but it is also robust for less than 5, whereas the chi-square test of independence is not. Like chi-square assumes that the observations are independent of each other and they're not related, and that the row and column totals are fixed, although that's a much more minor assumption. It's not present for the chi-square test, but practically it's one that's not often used in deciding to select this test because the alternatives are not well established. So practically that one is often not used. So if we go back to our original example of stress level and academic activity, the Fisher exact test would be a perfect test to use for these data, because we see that faculty, the number of faculty with a high stress level is 5, so it's a very small number of observations in that cell. So we could much more reliably use the Fisher's exact test to see if there's a difference of stress level based on academic activity. So in conclusion, we've looked at analyzing data. We've divided our data into subgroups and based on empiric considerations in the differences of percentiles. And then we've run both the chi-square test and the Fisher's exact test, which test the independence of two different categorical variables. So hopefully this is added to your analytic skill set. It's given you a lens to think about how to divide your data into categories that might be relevant, either based on observing the data patterns or based on theoretical rationale, and move you one step closer to answering your primary question and addressing the wicked problem that your team is considering. So enjoy analyzing proportions for equivalence, and we will see you next week.